2, 1. So formulas, here's an interesting challenge example for you. So it relates back to trying to isolate, substitute, and solve, and also figure out relationships between two quantities. So here's a formula that is given. It says consider the formula, so v plus 100 over t plus 5 equals to 20, and in brackets 3v plus 2r, and then all over t. So it's an interesting formula. It actually relates back. So you have volume, temperatures, and then you have a rate, r, there on the right-hand side. So the first question, or at least the first component, asks isolate for t. Now, if we want to be able to isolate this thing for t, it's going to be a little bit of work, but we can certainly try to see how well do we understand the isolation problem. So we have t in two places here. We have t both on the left-hand side and on the right-hand side, and in both instances, t is in the denominator, which is not something that we like. So how would we actually isolate for this t? Well, the first thing that we want to try to do is always get rid of denominators. And if you're going to be getting rid of denominators, then you can certainly multiply, okay, so both sides by t over 5. So if you do that, I'm going to just kind of do it one at a time. So if I did this on this side, and then I also did that on that side, that's going to get rid of, okay, this denominator for me. So it's going to cancel this off, but of course it's going to appear now in the numerator on the right-hand side. Now, that's the first thing. So what that leaves me with is this v plus 100 on the left-hand side, and it leaves me with all of this junk here on the right-hand side. Now, I'm going to just leave the junk for the moment, okay, on the right-hand side as it is. However, now I do want to get rid of that t on the right-hand side in the denominator. So I'm going to just switch this or shift this just a little bit. So if I want to get rid of this t, I'm going to do kind of the same thing. I'm going to multiply both sides by t. So I'm going to multiply this by t as well. So I'll kind of put this in brackets here. So the multiplication is very kind of vivid for us. So that t will now cancel this, and it will get rid of all my denominators. Now I have just basically an equation where t now is still on both of the sides, on the left and on the right. So how would I proceed to try to solve this? Well, I have to collect the t, so I have to bring them somehow together to one side. So what I'm going to do is on the left-hand side, I'm going to just rewrite this. So I'm going to put that t actually, so I'm going to have v plus 100 t. So I'm going to leave it. I'm not going to bring it into the brackets here just yet. It's kind of unnecessary because I want t on its own. Now on the right hand side, what I have is I'm actually going to simplify this a little bit for myself. I'm going to kind of bring this 20 inside here so that I'm not dealing with too many things. So this is going to be 60v plus 40r. So this is all still in brackets because I just put that in there. And then I have this t plus 5. Now at this particular stage, so what I'm going to do is, this whole thing is actually just one factor, right? And now I have two factors within this t, so that's 1 and 2. So sorry, I have two terms there. It's one factor as a whole in the bracket, but it has two terms inside. So what I'm going to do is I'm going to actually bring this and I'm going to multiply it through this, and I'm going to multiply it through that. Now, that is the same thing. So imagine if you had a number, let's say 10, and you had t plus 5, you know, you can bring this inside of this bracket like this. We would get 10t plus, well, in this case, it would have been 50. So I'm just distributing it across. Now I'm doing the same thing, except I'm doing it with the entire factor, which is 60v plus 40r. So what that's going to yield for me is 60v plus 40r t, so that's multiplied by this, plus, now I also have, that 60v plus 40r times that 5, right? But the 5 itself is actually a number that I have in there. So what I'm going to do is I'm going to just kind of rewrite this, and I'm going to kind of take it, okay, and then that 5 is still stuck there. So that is what I have. I have a t, and then I have a 5 over here. My left-hand side hasn't really changed anything. So I'm going to just carry it down. Now, what this allows me to do is now I have, okay, a t with some factor in front, and then I have another t with some factor in front. So I'm going to bring this whole thing, so this, over to the left-hand side. So that's going to be interesting because it's going to give me v plus 100 t minus 60v plus 40r t, and then on the right hand side all I'll have left is, now I can actually distribute this across, so I can bring the 5 over inside of this. So on the right hand side I'm going to have 5 times the 60, which is 300v, plus 20 times 5, which is 200r, so that's on the right hand side. And we're getting very close. Now I have this t here and this t here, so I'm going to now factor it out. So what that's going to leave me with is the following. I'm going to have v plus 100. I'm taking out the t, and then it's going to be, now this is, be careful there because it's minus there, so it's going to be minus 60v, and that minus of course works on both, so it's going to be minus 40r. And then the t has been taken out from the entire thing. On the right hand side I have 300v plus 200r. So quite a lot of work, but we're pretty much almost there. So now notice what happens. I have a v minus 60v, so these are like terms. So what I'm going to get, so 1 minus 60 is negative 59, so this is going to be negative 59v right there. This 100, so I guess that stays there, so plus 100, and then minus 40r, so that's going to be all in brackets there. And then I have all of this junk on the right hand side, so I'm going to just duplicate it, bring it down. And now if you want to solve for t, well, we have to divide both sides by all of this. So I have to take all of this and divide both sides by it. So here it is, right? And then I'm going to do the same thing. Let me make it a little bit smaller here. So on the right hand side as well. So there we have it. So I'm going to divide both sides so that this cancels with this. And now all I have left is t equals all of this. So now you have isolated for t. It's not the prettiest, right, of an isolation. There was a lot of work, but that's why I said this is a challenge. There's quite a bit of things to do, but it really forces you to think, how well do I understand, moving and isolating for a term, factoring things, and so on. So that's the first component. So this is done right there. Now the second item is, so now we have given t is equal to 5, r is equal to 1.5, solve for v. So that's the second component that we have. I'm going to steal this actually right here. So let's copy it. Let's bring it down. So here's paste. Okay, so we've done the first component, so I'll just erase all of this. And now this will be, a little bit easier because I'm just going to work with numbers. So I'm solving for v in here, but I am given what t is and what r is. So that makes my life simpler. So let me substitute all of this in, and let's see what we're going to get. We're going to have v plus 100 all over. So t is 5, so this is going to be 5 plus 5 is equal to 20, so this is going to be 3v plus 2 times 1.5. I'm just substituting that r in there, divided by, and this is going to be divided by 5. Okay, so now let's massage this out. On the left, I have v plus 100. This is going to be 10. On the right-hand side, so notice the 20 and the 5. So 5 actually goes into 24 times. So that makes my life a little bit easier. So 3v plus 2 times 1.5 is 3. Okay, so this is falling apart on us pretty nicely. I'm going to bring this inside. That's going to be 12v plus 12. All right, so that's what I have there. Now on the left-hand side, I guess I'll just keep it for the moment, but I'm going to get rid of that 10. So I don't want to have that 10 in the denominator. So I'm going to multiply both sides by 10. So it's going to get rid of this, and it's going to leave me with v plus 100 equals 2. So now multiplying, so both of these by 10, so that's 120v, and this is going to be plus 120. Now it's a much simpler type of formula in here. So what do we have? Let me just shift these things around. So it doesn't matter which side you pick. You know, I got to bring the v's together and I got to bring the numbers together. I see that the v, okay, the term on the right hand side is bigger, so I'll just keep it actually here. I'll bring the negative v over on this side, and then I'm going to swing this over to the other side. So 100 minus 120, so this is going to be 119v, and this is negative 20. So for this, dividing this by 119 on both sides, you have found your answer. So v is equal to negative 20 over 119. And now, if you want, although I guess it didn't really specify for us, but we can always just do the division if we wanted to know what the answer is in terms of decimal, and then probably you would have to round it to something which is convenient or that you're told. So if you want it as a fraction, so there it is, and then if you want it as a decimal, okay, there you have it. So that's part B. Now the third, okay, kind of item is, what is the relationship? So what is the relationship between v and r? Okay, well, v and r. Okay, so let's think about how we're going to do this. So I'm going to copy this. Now the relationship, is it linear? Is it non-linear? Is it other? So now other, like if you can, I mean, it's only linear or non-linear, but there's very special cases. Sometimes you have linear, which can be a direct proportion. So that's certainly linear. Non-linear, you can have a very special case in terms of an inverse proportion. But those are typically the relationships you run into. So within here, okay, so let's take a look and see. I'm going to paste this back in here. So we want the relationship between v and r. So what I like to do in these cases is, the ultimate goal is to try to match and see, okay, if I can, massage the formula so that it looks like this. Y is equal to mx plus b. The m is a constant, right? So this is some kind of a constant. Sometimes we use k. And the b is also a constant. So this is the linear relationship between y and x. Now, if we cannot come up with this match, that means that basically the relationship is nonlinear. All right, so what I'm going to do is, because they want v and r relationship, so I'm going to just take, v, for instance, right here, and then I have my r, which is right here, and I'm going to call them y and x. And then what I'm going to do is I'm just going to solve for y. Now, the relationship between the two, right, it doesn't really matter which one you call y, which one you call x. So that is actually irrelevant for us. So in this case, it's actually not going to be that terrible. So let me kind of get started. So which one should I call? Well, there's only one r there. So it's going to be actually easier for me to try to see if I can just isolate for r. So I'm going to call r y, and I'm going to call v my x. So everything else is a constant. So when we take relationships, they're constant. That means they're just numbers. So if you like, you can substitute a number. I actually just substitute, k. So then I go k1 is some constant. So let's see how I would do that. So I said I'm going to let x, okay, so that's my v. So it's going to be x plus 100 all over. Now, all of this is a constant. So I don't really care what t is. It's just some number plus 5. So that means it's just some number. I'm going to call that the whole thing just k1 is equal to, now my t in the denominator and this 20 again, okay, so this is just 20 over t. So that's the same thing as, 20 over some constant. So I can put this as constant, number 2, but this is just some constant throughout. So it's fixed. So that whole entire thing, actually, I can just call a constant. So this is nice because 20 over t is, I'm just going to call that a constant number 2. And then I will have in brackets. So I have 3. I said that my v is my x. And my r is going to be my y. So that's what I have. And now I have to isolate for y and then see if it resembles this. If it does not resemble that, then it's basically nonlinear. Okay, so this isn't actually that bad. So let's see what happens here. So I have, okay, I do have this k1 below. So, I can actually simplify this whole thing. Okay, so notice what this is. This is just 1 over k1x plus 100 over k1. Now, this is just a constant, and this is just a constant. So they're just numbers. So what I'm going to do is I'm going to kind of rewrite them. I used k2. So I'm going to say, okay, so let this be k3x plus, let's say, some k4. So anything that is not x or y, they're just constants, so I'll just keep relabeling them, 1, 2, 3, 4, so they're just constants. On the right hand side, I can actually bring this inside here. So what I'm going to get is I'm going to get 3k2x plus 2k2y. And by the same argument, this is just a constant in front of my x. So I've already used k4. So I'm going to call this k5x. And this, again, is just a constant. So it's 2 times some number, k2. So this is going to be, I guess, k6. That's what I'm going to call it. Now, notice, this is now, much, much simpler. And again, I'm trying to ultimately solve for y. Well, solving this for y is, it's not bad. I can bring this whole term to the left. Okay, if I do that, I'm going to get k3x plus k4 minus k5x is equal to k6y. Okay, so now, what is this starting to look like? I have in here, so this is, 2 like terms. So within those like terms, so it's basically k3 minus k5 x, right? So as I factor that out, plus k4 equals k6y. And again, by the same argument. So this is just nothing else but a constant. It's just some number. Okay, so I've already used k6. I'm going to call this k7x plus k4 is equal to k6y. To solve for y, I just have to divide by k6 on both sides. All right, so this is what I'm going to get. And so this is pretty neat because you're going to get y, so this cancels off. And you're going to get k7 all over k6x plus k4 all over k6. So that's very interesting. So notice this is a constant, okay, and so is this. And I just have an x there. So what does this look like? Well, you know, I can say that, well, this is some constant. Now I'm going to call this m. Okay, then I have an x plus, and I'm going to call this b equals to y. So what relationship is this? This is a linear relationship, right? So it actually falls off and nicely looks like this. So the relationship between v and r is linear. So that is pretty cool. And it was a little bit of work, but it forces you to try to understand what happens when you want to find a relationship between two variables, and then what's the procedure. So I basically call one x, one y, because I'm just so used to working with that, and then everything else is just constants, right? Now I don't know what those numbers might be. That's why I started calling them k1, you know, k2, and then k3, and you just keep going, okay, as you're running through. So this is definitely a challenge. If you were able to solve this, or you were able to follow it, huge thumbs up to you. All right. Okay, so thanks for watching. Hopefully we'll see you in a future video. Bye, everybody.